Hello everyone. In this video, I'm going to create a gigantic black hole the size of the Milky Way, and then collide galaxies of different sizes with it, including the Milky Way itself. Let's see if such a galaxy-sized black hole can swallow an entire galaxy. We'll do all this using the Universe Sandbox simulator as an example. Let's go. Let's start the experiment. I'll start by taking a black hole with a mass of 10 million suns and place it somewhere around here. And yeah, it's hard to see, so I'll change the background to make it easier to distinguish. Let's go with, well, let's set it to this particular shade of green for the time being. And basically, we need to make it the size of an entire galaxy. Here are some examples like the radius of the Milky Way. I'll choose this value and just set it to 1. And there we go, we have such a black hole now. I'm starting the time and everything is fine with this black hole. So, the black hole ended up with a radius equal to that of the entire Milky Way galaxy, and its mass is 117,425 times the mass of the Milky Way galaxy. Incredible. Now we can bring back the normal background. And let's start with the smaller galaxies. So the small Magellanic Cloud, I'll place it somewhere here, and I'll also take the large Magellanic Cloud, which are satellites of the Milky Way, and put it somewhere over there. Here we have the large Magellanic Cloud galaxy, speeding up time. Let a decent amount of time pass. Here it's probably more than 10,000 years per second. And now we can already see some changes happening to this galaxy. I'll speed up time a little more and more and more. And as we can clearly see, the entire structure of the large Magellanic Cloud galaxy is being utterly destroyed, and now the galaxy no longer truly looks like itself. And now we observe this stretching effect directly toward the black hole. Here we also have the small Magellanic Cloud, and precisely the same thing is happening to it. Obviously, the black hole will most likely completely consume them, because our black hole is the size of the Milky Way, and these galaxies are much smaller. And now they're approaching the black hole. Let's take a moment to watch this, and here we clearly see this significant stretching, this noticeable elongation happening. And the second galaxy also passed by like that, but it wasn't consumed. Look, here we have the large Magellanic Cloud, and it just scattered completely like this, so the black hole simply destroyed them entirely. And right next to it is the small Magellanic Cloud. Alright, let's take off our space glasses. Now it's a bit brighter, should be clearer, and I'll speed up the time even more. Oh. Now it's like, you absolutely cannot see anything at all. Let me quickly set this green background again so we can clearly make something out. Or perhaps just plain black. Oh, this way, it should be better. And as we can see, the black hole didn't absorb all the particles. Some nebulas are still here. Maybe some stars are orbiting the black hole. And something like an accretion disk has formed. It's not really clear. So that's basically how it all looks. And now it's time to set the Milky Way on a collision course with this giant galaxy. I'll place it somewhere right here. So here it is in all its glory, our galaxy. I'm speeding up time, and let's see what happens to the Milky Way and how the black hole will deal with such a large galaxy. At this point, their sizes are almost equal. So far, everything seems to be fine. I'm speeding up time even more? Well, so what? What's going to happen? Okay, now something seems to be happening. Yes, the structure is breaking apart, just like with the large and small Magellanic Clouds. As you can see, everything is stretching out. Where's the black hole? The black hole is right here, and it's rapidly approaching. I'm slowing down time. Now this edge of the galaxy is about to collide with the black hole. And this is how it absorbs everything. Look, now the center is about to be absorbed. It just swallowed Sagittarius. And right away, there was this kind of outburst. Lots of matter shot out from the black hole, and not all the particles were absorbed either. Well, I guess now they'll either come back or just fly off further. Some of them are being pulled in, but the black hole is so massive that it will start attracting them. That's pretty obvious. Let me also turn off the space goggles. Man, it's not really all that bright or visible. But now everything is coming back, and you can see how the particles just fly in. The black hole is scattering everything around. Well, basically, it's clear. It's something similar to the previous experiment where I collided the large and small Magellanic Clouds. This giant black hole just destroys galaxies. By the way, I see that the mass of this black hole didn't even increase after all that. Now I'm going to carefully take the magnificent Andromeda galaxy and gently place it somewhere over here as well, and then let's observe precisely how this incredibly powerful black hole deals with a much larger galaxy, because if my memory serves me correctly, the Andromeda galaxy is approximately twice the immense size of our own Milky Way galaxy. So, let's speed up time and see what happens to this galaxy. Speeding up. Alright, something's already starting to happen. Here we also have Andromeda, a spiral galaxy just like the Milky Way. Again, its overall shape is being completely destroyed by the immense gravitational pull of this galaxy. And where exactly is our supermassive black hole? It's right here. And the galaxy is rapidly approaching the massive black hole. How the cigar becomes so elongated in its shape. Look at that shape. Where's the black hole? Here's the black hole, I'm slowing down time. And now, this very edge is about to completely enter the vast, dark black hole. Oh wow. The galaxy is stretching out incredibly. And now it's about to reach the center. The central black hole in the Andromeda galaxy, that's the black hole. Well, let's see how this happens. I'll slow down time here. So, this is the black hole itself, there it is. If I manage to fly over there in time, I'll show you. There, I showed it, right? We're moving away, moving away, moving away, until that black hole reaches here. Looks like I was a bit too late, but that's okay, you didn't really miss anything. Basically, it's a similar situation to what happened with the Milky Way. But here, there are definitely more particles. Let's see what happens next with these gases. So, some are being pulled in, some are flying away. Yeah, basically it's all pretty much the same. Although not everything flew away, everything came back. It came back and we see a similar picture here. Well, everything is clear here, basically. Let's move on to the next galaxy. And the very last galaxy I'll be taking a look at is truly one of the largest known galaxies, IC 1101. I'll carefully place it somewhere over here. This is precisely what such an absolutely gigantic galaxy actually looks like. It's really truly incredibly huge, guys, believe me. It's extremely immensely huge, much bigger than that supermassive black hole the size of the entire Milky Way. If we were to turn on the so-called human eye mode, this magnificent galaxy would appear even more remarkably brighter to us. Well, for example, in this simulator. So, let's speed up time and see what happens to this galaxy next. Let's see how the black hole will deal with it. It'll be something similar here as well. Here again, everything is being stretched out. Let me slow down time. Everything is being stretched, as I understand it. All the galaxies here. And the black hole is scattering these gases. As you can see, it's spreading them around. And here, it can't just absorb everything so easily. I'm speeding up time again, and the truly enormous black hole just flies along this incredibly stretched out galaxy and basically utterly destroys it completely. You can see for yourself what's happening. It's just truly incredible. Let me speed up time a little bit more, and basically it has scattered all of these nebulae from this galaxy. Well, the galaxy was basically a sphere, and now this sphere has taken on a slightly different shape, more diffuse really. And it no longer looks like the structure of an entire galaxy, it's as if we just have separate pieces of a galaxy, lots of small galaxies from one huge one. And the black hole keeps sucking all of this in. Look, it's not clear here whether it's absorbing them or scattering them, but as I look, the mass of the black hole still doesn't change. Here it says 425 Canzabella, and it stays that way. And that's how everything happens if you look from afar. I'll speed up time here again. They're speeding it up even more. How much time is passing here? It says 50 mega years. And if we zoom out, we see that some particles are already flying away nicely from here. The black hole no longer attracts them. It seems the simulator doesn't allow us to speed up any further. Yes, so this is basically the picture we ended up with. You could say it's some kind of strange galaxy we've got here. Anyway, let me know in the comments what kind of structure we've ended up with from this experiment, because it's hard for me to call this a galaxy. And finally, I want to crash all these magnificent galaxies into this colossal black hole together. So, once again, the small and large Magellanic Clouds, the vast Milky Way, the impressive Andromeda galaxy, and the truly enormous galaxy IC 1101. This time, all these incredible galaxies will collide with the powerful black hole together. I'm speeding up time. We won't watch up close what's happening to the galaxies. It's all clear enough. The main thing for us is to quickly take a look at everything from afar. So, we can see that everything is getting stretched out again, the black hole is letting everything pass through like this. And now IC 1101 is already starting to get torn apart, a lot of particles are flying through here. Let's see, yeah, the human eye mode is on here and it's even lagging a bit, wow. Well, there are a lot of objects as you can imagine. The processor immediately gets overloaded. I'll speed up time even more. Well, it turns out to be something pretty similar to last time. Basically, most of the particles here are from IC 1101. There's one more thing I want to show. I managed to create an accretion disk, a proper accretion disk from the Milky Way. If you were to place the galaxy quite close by, let's just put it somewhere around this particular area here. We're running at 5,000 years per second, but I'm speeding up time even more. Speeding up, speeding up. Here we have the magnificent Milky Way flying gracefully in, and if you carefully position it like this, the black hole forms something like a swirling accretion disk. It looks pretty cool, of course. If you look at it like this, it really does look like an accretion disk. If you were to slow down time and zoom in very closely like this, it actually looks quite remarkably similar. Well, you could also put it into a much closer orbit, just to be absolutely sure. And now I am speeding up time significantly, and at this point we can clearly observe an accretion disk forming from the numerous galactic particles. Well, that's pretty cool, of course. So that's precisely how it ultimately turned out, guys, and those are the comprehensive results of these interesting experiments. Please do leave a like if you thoroughly enjoyed it, and kindly let me know in the comment section below what you truly thought of this particular experiment. Thank you very much indeed for watching, and I look forward to seeing you again in the vast universe.